All right, can everybody hear me?
Yes, you're coming through loud and clear.
Excellent. Well, it's 12 o'clock. We'll go ahead and start. My name is Eric Dietz. I'm with Exact Metrology. And for today's webinar, we'll be going through RDS. As most of you know, RDS is the interface software between the roamer arm and whatever third-party inspection software you're running. It also allows you to recalibrate probes, check the arm's accuracy, and repeatedly modify things like sound and button functions. The most current version, 4.1.0.4258. I'll show you how to find that. There's a couple ways to access RDS. The way that I usually go about it is in your hidden icon system tray down in the lower right-hand corner. And right now, it's a little arm that's green because it's connected. It's red if it's not connected. It's always running in the background. So if you hover over the icon, you can right-click on it and go to About. This will show you your current version. The other way to access your RDS is through the Start menu, All Programs, find RDS, and here's some of the same files you'll find over in the other system tray. We're going to start by accessing the Rds Toolbox up at the top.
Okay, we'll look at it before we start the next chapter.
In your toolbox, you'll see the first panel. It's called News. So if there's anything new released from Hexagon about RDS, you can typically find it in here. To navigate this, you can refresh and then close it out. We're going to go back to the home. And if anybody has any questions when I'm in one of these, just go ahead and speak up. I'll stop. The Smart app here lets you check your arm out. Tells you way more information than you're going to ever want to. If you scroll over parts of the arm, it can tell you all about it. This is very general information over here on the right. If you want detailed information on parts of your arm, you can just left click on any of these items. Feature pack. Also, the connection that you have going on, if it's working properly. If you're running Wi-Fi, I'm not right now. They also have, let's see, analyze indicators. This is a lot of information that we typically don't go over, or we typically don't use, but Romer/Hexagon may want you to access this at one point to let them know information. But typically you're not going to be in here. If we move down, we have access RDS control panel. This opens up the ARMS control panel. You can also access it from the RDS icon. Second one down. Same thing with the start menu. Right there. We're logged in as standard user right now. If you want to switch to advanced user, it's exactly how it's read, advanced. And all that does is allow you to access a couple other features inside of your control panel. If we start with the summary, the summary just tells you general information about your machine, your current probes, and your status. Your connection just shows you what you're hooked up to. If you want to switch over to USB, Wi-Fi, whatnot. We have our general parameters. Turn up our volume, turn it down. Select a language. The probe section allows you to see all of the current probes calibrated for the machine. Typically, ARMS nowadays have their center reference probe. They're 3 millimeter, they're 6 millimeter, and if you have a scanner, it will allow you to check your probe from here, but we'll get into that a little bit later when we go into the data collector. If we go to the View tab, it just has a lot more information in here. These dimensions get compiled after a calibration. The Smart section will allow you to turn on and off some of the RDS notifications and the transmission of smart data to Hexagon if you're in advanced mode. So Hexagon is always, they can access your ARM if you're hooked up to the internet. And also the notifications, you'll see them sometimes pop up in the lower right-hand corner of the screen, telling you about news and maybe updates that are available. To get into reference, you have to be in advanced user mode. But if you are logged in, you can upload coordinate systems, perform leapfrogs. Those are also known as station relocations. But those are typically done in your third-party inspection software. I wouldn't advise doing them inside of RDS. If anybody has ever heard of or dealt with a grid lock, this is what Hexagon uses to help them create a grid lock at a customer's site. Advanced settings allows you to change your button configuration. Allows you to turn on and turn off your remote mouse. The remote mouse it allows you to move the mouse using the arm. It was more popular with legacy arms. You can also turn on, turn off your haptic feedback, the little vibration that you get. I would stay out of access control. And features can allow you to unlock features such as run single arm calibrations, upgrade firmware of the RS scanner, but these require an activation code from Hexagon, and they're not typically relinquished to many customers. So chances are you won't be using this either. And then about is just more system information. Moving on, we'll go into the vault. Here you can view all the arms that you've been connected to. And it allows you to pull all kinds of information from the arms. If you are connected to the internet, you have access to packet information, download, and you can back up any of the packages. But they are already backed up to Hexagon's database. So it's not a practice that people typically do anymore. But if you were to highlight something, you can, let's see, I believe it's here, download. You can back up items directly from the arm that you're connected to. Move on to arm status. Here you can view your connection status, and arm properties, similar to what you saw in the RDS control panel. If we head over to maintenance, it opens up a new set. We have program a probe. Here you can program new nominal data for the probe itself. If you were to purchase one of these probes, which I haven't done in a very long time, but I believe in the new RDS, you come in here and to upload nominal data. You can configure your Wi-Fi chipset. This allows you to reprogram items in the feature pack, such as the IP address or subnet mask. View logs lists all system events, assuming you have any. Upgrade ARM's firmware. Obviously allows you to upgrade the firmware to specific boards on the ARM. And again, you won't be doing any of this unless requested by maybe Exact or Hexagon. And Encoder Analysis. This can allow you to dynamically test and view encoder output. We don't have any issues right now to look at, thank God. Does anybody have any questions on the Rds Toolbox? All right, I'm going to move to the Rds Data Collector next. And I'm going to access it from the tool tray. Right click on the RDS icon. And we have Rds Data Collector. In here we have scripts we can select from. Our modules up top. Calibrations. Check to certs. And diagnostic tools. Typically you'll be doing diagnostic tools. And we're going to start by doing a probing quick check. We're going to highlight this and we're going to run. So automatic starts with length. Your steps down here, length, cone, sphere, plane. That automatically opened up length. If it didn't, you can always double click on it to play the step, or highlight it, play all, or play step from the buttons down in the lower left-hand corner. When doing a bar length, it will keep in the nominal value from the last length bar you entered. But you want to confirm that this number is the nominal number on your cert that comes from Hexagon. I'm going to say OK. You'll see down on the bottom of the screen, we're in the home position right now. The arm is at rest, upright. It's looking for 0.1 out of 10 points. I'm going to walk through the length check, and then I'll show you how I did it and what our result looked like. As you can see, there's a visual on the screen of where the gray is the arm that I have. You don't have to have it in the exact position that the blue one is in. So I went through and I measured 10 points on our length bar. We started on the right-hand side, then we moved to the left and we went back and forth. We have a 7-axis with a scanner with us today. So these are our length check positions suggested to us by Hexagon for a 7-axis arm. And if any of you would like a copy of this, email me and I can send it to you. I also have the 6-axis arm positions when performing a length check available. When the results automatically come up on the screen after the 10th point is taken, what we're confirming with these numbers is the minimum deviation and the maximum deviation are at or below the spec of our arm. So our highest value, 22 microns right now. If I pull up the spec for our arm, we're running, we happen to be running a 75-25, 75 series. So our volumetric accuracy is 38. And we are at or below in the min and the max. So we're good. Does anybody have any questions about doing and performing length checks? Okay. If you want to do it again, if you get bad results, you always want to check your setup and then hit back and try it again. We're going to hit finished. The next step through is the cone. And let's see here. I'm going to leave the 15 millimeter probe in, and I'm going to go to place. So we can see here at the bottom of the screen, we're in the home position. We're taking 1 out of 10 points. And the stationary location for the cone or the conical seat that the ball's being is not to move during the 10 points. I'll go ahead and take them now. All right, after the 10th point, software's algorithm runs and automatically pops up a dialog box with the results. What we're going to be looking at here is the range over 2 in the X, the Y, and the Z. We have 9 microns, and a little over 14. I don't think I have a picture of the results. But if you look at the search that comes with your arm, you look at the point repeatability spec, range over 2, for the arm that we are operating here today. The range over 2 should be at or below 27 microns. And we have met that. Our greatest outlier is 14. So we are at or below there. If it was out, we would look at our setup, confirm everything is solid, back up and try it again. Since it's good, we can go ahead and select finished. Does anybody have any questions at all on the cone check? And we would suggest to do this with the 3 and 6 millimeter. I'm assuming you'll be using that for whatever measurement sequence you'll be doing. All right. If we have a scanner, we're going to go through how to do a scanner check. If you have a 7-axis with a scanner, your arm should come with a calibrated sphere that you're going to use as your reference. So to exit this script, we're going to go back to open a script. And from our diagnostic tools, we can, instead of going to probing quick check, we can go to scanner quick check. We can hit run, or we can just double click on scanner quick check. It says no probe detected. I have to hit the switch on the back of the arm. When you turn on your scanner, your RDS scanning box opens up in the corner. The little button takes you to the control panel, opens up your RSX, it's your scanner, and allows you to change items in here. Capture mode is something people change the most often. Keep button pressed will allow you to hold the trigger button as you're collecting data and then let it go when you're done. Press to start, and to stop will allow you to tap the button to begin scanning, and then tap the button to stop scanning. You can change your point sampling. I'm going to leave it at 33. Switch exposure modes. I'm going to go ahead and save this since I did modify my capture mode. In your steps on the left-hand side, there's a plane, a sphere, and a ball bar. The sphere is the artifact that typically comes with the arm when it's purchased. I would suggest using this one to check your scanner out. Either double click on the sphere, or you can place step down the lower left-hand corner. It's always going to have your last sphere diameter automatically loaded up in there. Select OK. Saying I'm in the home position. Please measure the sphere. Typically, you're going to take 5 scan passes when you measure the sphere. Your scan pass positions are going to look like this. If anybody needs this information sent to them, just email me, message me, let me know. I'd be happy to share it. I'm going to walk through collecting the data. Pass 1. Pass 2. Three. Four. And 5. After you take your 5th pass, it will not automatically run its algorithm and give you results. You'll have to press the right trigger. And it begins its calculation. If we look at the results, what we're confirming here, on your cert, in your set of certs that come with the ARM, you're going to have a scanning system verification report. And on that report is a system accuracy spec. For the ARM we're working with today, that spec is 63 microns. And what we're verifying on these results is that your subsphere's quality standard deviation is at or below 63 microns. And ours is just over 16. So we know this scanner is good to go. Again, if you are above, you want to check your system's setup, make sure it's stable, hit back, try and run it again. If you cannot get it in, you would typically call Exact if we sold you your equipment, or get a hold of Hexagon, and we'll be able to get it figured out. Does anybody have any questions on doing a sphere scanner check? If not, I'm going to hit finished. Let's look at what else we have up in the data collector. Machine status shows us a lot of information on our axes. When I start moving the arm around, we can see that all the encoders and axes are running properly, just because of the ticker that keeps moving and updating. We can change from standard to advanced user still. We can access our control panel again. Show our header logs. About, and again, that can be accessed in a lot of different places. We can go ahead and quit. Closes it down. I'm going to also close Rds Toolbox. I'm going to switch back out to the 15 millimeter probe. All right. So if we go back to our RDS icon, and we'll take a look at the quick measure tools. These have been offered through Romer for quite some time, at least as long as I know, over 10 years. These are very simple measurements. They don't get recorded anywhere, but without a third-party inspection software, they still allow you to take measurements on the fly. We'll walk through a couple of these. Hole diameter. And you have to read the instructions. Measure at least 3 points on a plane. Reason being is a hole is a two-dimensional feature, so it requires a three-dimensional feature to determine its axis, where it's IJK. So we're going to go ahead and measure 3 points on a plane. I hit the right mouse click, or I'm sorry, the right button click on the arm itself, and it moves ahead to the circle. The instructions are take at least 3 points on the circle. Once you have the points collected, you can hit the right button click on the arm. And it automatically pops up your diameter. Again, these results don't get saved anywhere. But if you need a quick check for a circle, it's an easy way to do it. Distance between 2 points. It's pretty self-explanatory. You're just going to measure 1 point, measure the second point, and it's going to give you a three-dimensional distance. Distance between 2 points, 1,523. I'm going to say OK. And I'm just going to do one more of these. Angle between two surfaces. So this is measuring 2 planes. And it's just going to give you the measured angle between the 2 planes. Measure at least 3 points on the plane. And it will allow you to measure more than the bare minimum. Then right click on the arm to move on to the second plane. Right click on the arm to complete it. Automatically pops up in the 2 planes. Does anybody have any questions on the RDS quick measures? And go ahead and hit done to exit. We'll go in RDS. Calibration of a probe. First, I'm going to switch out. We cannot calibrate the 15 millimeter master probe tip. So I'm going to switch it out to the 6 millimeter. Same thing, I'm accessing it the same way. Where the RDS icon is, right click. Calibrate current probe. There's a couple options. Hexagon, I recently read, likes sphere with reference probe. We typically do single point. I'm going to go over single point. So again, it's in the home position. It's sub-step. It's 4 points from right to left. That's the wrist orientation. You're gonna have a total of 20 points by the time it's done. And you'll see the orientation by the view of the CAD view here. All right, I have my conical seat out in front of my arm directly. During this exercise, it's a little more important to try and get the actual arm to turn from gray to green in its positions. So you'll see they start to turn green once they get orientated correctly. And it will allow you to take a point if you're not orientated correctly. But the left arm click will allow you to delete the point you just took, just in case you don't want it. So starting from the right, I'm going to pull the trigger button. Got my first point. Second. Third. Spin the wrist around. We got fourth. Fifth. And I try not to pull the probe out of the conical seat during this sequence. After the 20th point, it automatically runs its algorithm. Again, our range over 2 numbers seem to look very good. When we hit finished, it moves on to the next step in line. It runs a calculation. It shows you residual error, 16 points here. And asks you, do you wish to use the calculated calibration? I'm going to go ahead and say yes. And I'm going to leave it the same default name. Unless you have another name, you can go ahead and enter it here. I'm going to leave mine 6mm ruby tip and say OK. Specs will now be updated. Would you like to continue? I'm going to say yes. So now it has saved the specs for that resistor pack with that tip onto the board on the arm itself. So anybody else who plugs into that arm will have the updated specs. And I'm going to say OK. Now it automatically takes me to the next step, which is checking the probe tip. And it's the same 10-point sequence as we did earlier with the cone check. Again, I don't believe it's as important in this operation to get all the joints of the arm green. After the 10th point, your range over 2 results for the X, Y, and Z come up. We have obtained 7 microns, just over 12, and 26. If I look at my certificate of traceability for this arm, we're again looking at the point repeatability spec, range over 2. It's still got to be at or below 27 microns. Looks like we just made it in the Z. So this probe is in spec. Does anybody have any questions on calibrating probe tips? Does anybody have any questions on RDS at all today? All right, again, my name is Eric Dietz with Exact Metrology. If you need to get a hold of me, feel free to email me at Eric D as in Delta at exactmetrology.com, and I can send you any screenshots or information I have on RDS. Thank you for joining today. I hope you all have a great day.